Dear students, welcome to s.mathguru classes. So our main discussion is variation of parameters. We solve some problems. Now we consider the remaining problems. All of these are very easy, very interesting. But just using two formula, we can easily find the variation. We can easily solve the variation of parameters. Now let us consider one problem. Apply the method of variation of parameters to solve d²y dx² minus 3 dy dx plus twice y equal to e to the power x by 1 plus e to the power x. Now we want to solve this problem. So first we convert this capital D minus 3d plus 2. Y is common, and on right hand side e to the power x by 1 plus e to the power x. We get this. So d square dx square means capital D, d dx means capital D, this is d square, this is d, and 2y is common. And auxiliary equation equal to m square minus thrice m plus 2 equal to 0. This implies m square minus twice m minus m plus 2 equal to 0 if we factorize. Then m common, we get m minus 2 minus 1 common, m minus 2 equal to 0. Then m minus 2, m minus 1 equal to 0. And this implies m equal to 2, m equal to 1. We get this one. Now we have to write complementary function. Complementary function equal to c1 e to the power x plus c2 e to the power twice x. This is the complementary function, this one. Now particular integral. So here we get y1 equal to e to the power x, y2 equal to e to the power twice x. We consider this. Now particular integral pi equal to uy1 plus vy2. These are particular integral. Now first you have to find y1 y2 dash minus y1 dash y2. What is the value of this? So this implies y1 means e to the power x, y2 dash, the dx of this means 2 e to the power twice x minus y1 dash, the dx of e to the power x means e to the power x, and y. So first this one, y1 dash this, and y2 means e to the power twice x, and this is 2 e to the power thrice x minus e to the power thrice x. This equal to e to the power thrice x. You get 2 minus 1, then we get e to the power thrice x. Now first you have to find u equal to minus y2x by y1 y2 dash y1 dash y2 dx. This is our u equal to y2x minus y1 y2 dash minus y1 dash y2 this. Now y2 minus y2 means e to the power twice x. This is our y2. And x means right hand side. Right hand side is this, e to the power x by 1 plus e to the power x. E to the power x by 1 plus e to the power x divided by this y1 y2 dash minus y1 dash y2. This value is e to the power thrice x. So we get e to the power thrice x. We get this. And this will be minus e to the power thrice x by e to the power thrice x 1 plus e to the power x dx. This one we get. So e to the power 3x, e to the power 3x cancel. We get minus integration dx by 1 plus e to the power x. We get this. Now, how to solve this problem? This is minus. We multiplying numerator and denominator by e to the power minus x. For solving this problem, we multiplying this. And if we multiplying, then e to the power minus x and this into this e to the power minus x, this into this e to the power 0, this is 1 dx. So, this minus we write inside this, we write here. But if we differentiate this e to the power minus x plus 1, if we differentiate, we get minus e to the power minus x. This result we get. That means we know a formula, integration f dash x by fx dx. This is log modulus of fx. We know this formula plus c. The integration f dash x by fx dx log modulus of fx plus c. That means if differentiation of denominator given in numerator, answer log of denominator. So, differentiation of denominator given in numerator, then answer log of denominator, or we can add modulus also. This is our u. So, u equal to we get log e to the power minus x plus 1. Now, we want to find v. So, v equal to integration y1 x by y1 y2 dash minus y1 dash y2 dx. y1 means e to the power x and x means this one e to the power x by 1 plus e to the power x. This value is e to the power twice x we get. And this is e to the power twice x, then 1 x is here, we get ultimately dx by e to the power x 1 plus e to the power x, this one we get this. So, if we this multiplying, then e to the power twice x and this one 3x minus twice x is x and this one here. Now, we integrate this directly 1 by e to the power x minus 1 by 1 plus e to the power x dx, this, and we integrate this one dx by e to the power x minus integration dx by 1 plus e to the power x, and this e to the power x taking in numerator e to the power minus x dx, and this is multiplying numerator and denominator by e to the power minus x. This is e to the power minus x 1 plus e to the power x dx. We get this. Now, integration e to the power minus x means minus e to the power minus x, and this minus taken inside the bracket, inside integration e to the power minus x multiplying this e to the power minus x plus 1. E to the power minus x into 1 is e to the power minus x, e to the power minus x into e to x, e to the power 0, this is 1. So, again we get differentiation of denominator given in numerator. If we differentiate this, then we get minus e to the power minus x. This differentiation given in numerator, I recall the formula integration f dash x by fx dx. This is log modulus of fx plus c, this one. So, this differentiation given in numerator, answer is log modulus of e to the power minus x plus 1. This is our v. So, we get u and v. Here we get this. Therefore, particular integral equal to u y1 plus v y2. U we know log of e to the power minus x plus 1. y1 is e to the power x. and v means minus e to the power minus x plus log e to the power minus x plus 1. We can write modulus or without modulus, and e to the power twice x. So we write in this way: e to the power x log of e to the power minus x plus 1. This is we write first, and multiplying with this minus x plus twice x, e to the power x, e to the power twice x log e to the power minus x plus 1. We get this one, we get particular integral, we get this one. Now general solution is y equal to cf plus pi. Cf means c1 e to the power x, c2 e to the power twice x, and pi just we get e to the power x log e to the power minus x plus 1 minus e to the power x plus e to the power twice x log modulus of e to the power minus x plus 1. So we get this cf, this is cf already we know this, plus pi is this, and this is our final answer. Very easy solution, just putting the values, the uv, just putting values for in formulas, ultimately answer will come. Here another problem solved by method of variation of parameter d square y dx square minus y equal to 1 plus e to the power x 1 plus 1 by e to the power x whole to the power minus 2. This one you have to solve. I rewriting this line d square y dx square minus y, if we taking LCM e to the power x this plus 1 whole to the power minus 2, and this implies d square minus 1 into y. If we taking reciprocal, then this is e to the power x plus 1 whole square. This minus will be plus if we taking reciprocal. Now this will be d square minus 1 y e to the power twice x by e to the power x plus 1 whole square we get. This one we get. Now auxiliary equation, this is m square minus 1 equal to 0, m square equal to plus 1, m equal to plus minus root over 1. So m equal to plus minus 1. Therefore, complementary function equal to c1 e to the power minus x, c2 e to the power x. We get this one. This is our complementary function. Now here y1 equal to e to the power minus x, y2 equal to e to the power x. Now y1 y2 dash minus y1 dash y2, what is the value? y1 means e to the power minus x, y2 dash, this is ddx of e to the power x, e to the power x, minus y1 dash, this is minus e to the power minus x, and this is y2 means e to the power x. So this is e to the power 0 minus minus plus e to the power 0, 1 plus 1, this is 2. We get this value is 2. Pi particular integral equal to uy1 plus v y2. These are particular integral. First we find u equal to integration minus y2 x by y1 y2 dash minus y1 dash y2 dx. Integration, this value we get 2 and minus y2 means e to the power x and x means this right hand side. This right hand side is x. This is e to the power twice x by e to the power twice x by e to the power x plus 1 whole square. This dx and minus 1 by 2, we arrange this e to the power x whole square e to the power x plus 1 whole square and this e to the power x we write here e to the power x into dx. We can write in this way. So this one we write. So we consider e to the power x plus 1 equal to z. Let e to the power x plus 1 equal to z. If we differentiate both sides with respect to x, then ddx of e to the power x is e to the power x. This is 0 and directly write dx equal to dz. I left two steps. Ddx of e to the power x, e to the power x, this is 0, this is dz by dx and this is dx multiplying left hand side, we get this. So we get this is minus 1 by 2 e to the power x plus 1 we consider z and e to the power x will be from this e to the power x equal to z minus 1. So this is z minus 1 whole square and e to the power x dx, e to the power x dx means dz. We get this and minus 1 by 2 remains same. This is z square a minus b whole square a square minus twice ab plus b square dz. Minus 1 by 2 integration z square by z square 2z by z square 1 by z square dz. 1 by 2 minus this is 1 2 by z 1 by z square dz. We get this. Now I integrate this minus 1 by 2 dz, this one, and minus minus plus 2 to cancel, dz by z, dz by z and minus 1 by 2 dz by z square we get. And integration dz means z, dz by z means log modulus of z. 1 by 2 this is minus 1 by z. Integration dz by z square means this because we know this formula integration dx by x to the power m, this equal to minus 1 by m minus 1 x to the power m minus 1 plus c. Dx by x to the power m minus 1 by m minus 1 x to the power m minus 1 plus c. So here m means 2, 2 minus 1 is 1, 2 minus 1 1, directly we get minus 1 by z. And this is minus 1 by 2 z, z means e to the power x plus 1, e to the power x plus 1 log e to the power x plus 1 minus minus plus 1 by 2z, z means e to the power x plus 1. We get this. This is our u. U is this. Now our requirement v. V equal to y1 x by y1 y2 dash y1 dash y2 dx. y1 means e to the power minus x, and x means e to the power twice x, e to the power twice x by e to the power x plus 1 whole square, and this is 2 we get dx, and this will be 1 by 2, this minus this, if we multiplying, then e to the power x, e to the power x plus 1 whole square dx. Again, if we putting the same values, 1 by 2 e to the power x plus 1 already we taken, this is z, and e to the power x dx means dz. So this will be 1 by 2 minus 1 by z. If we using this formula, we get this, and this will be minus 1 by 2z, and z means 1 by 2, z means e to the power x plus 1. This is our v. Now pi equal to u y1 plus v y2. U means this one, minus 1 by 2 e to the power x plus 1 log modulus of e to the power x plus 1 by 2 e to the power x plus 1 into y1 means e to the power minus x plus v y2. V means this one, this is minus 1 by 2 e to the power x plus 1 into y2 e to the power x. These are v, and y2 means e to the power x. And all the terms we multiplying by e to the power minus x, 1 by 2 minus 1 by 2 e to the power minus x, e to the power x plus 1 plus e to the power minus x log e to the power x plus 1 e to the power minus x by 2 e to the power x plus 1 e to the power x by 2 e to the power x plus 1. We get this, and from these two terms, e to the power x plus 1, e to the power x plus 1 common, and if we now these two terms remain same, minus 1 by 2 e to the power minus x e to the power x plus 1 e to the power minus x log of e to the power x plus 1, and from this these two are LCM, e to the power x plus 1, 2 into e to x plus 1 LCM, e to the power minus x e to the power x. We get this. Now these two terms are remain same, 1 by 2 e to the power minus x e to the power x plus 1, and this is e to the power minus x log of e to the power x plus 1, and from this taking minus sign common, and e to the power x plus 1 also common, then we get, if we taking minus sign common, then e to the power x minus e to the power minus x by 2. We get this one, and these two terms are remain same, e to the power minus x e to the power x plus 1 e to the power minus x log of e to the power x plus 1 1 by e to the power x plus 1, and this is sine hyperbolic x, because we know this formula, sine hyperbolic x equal to e to the power x minus e to the power minus x by 2. We get this one. For this value, we write sin hyperbolic x. General solution is y equal to cf plus pi. This implies y equal to cf means c1 e to the power minus x, c2 e to the power x plus pi. Pi means this 1 by 2 e to the power minus x e to the power x plus 1 plus e to the power minus x log of e to the power x plus 1 minus 1 by e to the power x plus 1 e to the power x plus 1 sine hyperbolic x, and this is our final answer. This is very easy solution, very interesting. Just only one formula you use here, otherwise all of these are same. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.